So you get to go pull this crate off the shelf, and it's going to help you guys with your NGSS standard around matter and its interactions. And you're going to be focusing on materials and their properties. You'll have such fun with the periodic table in these labs. You get to explore the periodic castle of elements, and the kids love this visual. It came to us from one of our submitting authors, and they envisioned the periodic table as a castle. Can you come up here, and you two come up here, because you were such good explainers. You talk first, and then we'll have you explain your thing again, okay?
I'm wearing a Sciencey Galaxy jacket.
Yeah! Okay, go for it, Mr. Marvel.
Ryan's been trying to overthrow me and take control of the class.
Sorry, Mr. McGraw.
So this is good, yeah.
The periodic table is a chart where all of the elements that have been discovered by scientists have been on here on this chart for like decades.
So it's so fun when they get this on their desk and all of them are like, can I keep it? They love this periodic table. And for them to really work with it, but hold these elements in their hands, and elements that they might not normally ever get to see. Some of these elements I didn't even see until college. So it's really a unique experience for them, and they love testing these elements, and they're all safe for them. So we will start by showing you what's in the COA. You're gonna get little Sami Sampler. He's come into your classroom, and Sami Sampler is excited to share 6 samples of this periodic table. Now, all of these sets contain the same elements, and your students will get this as their lab sheet. And these are their pocket pets of each individual element. If you just let them do it all on their own, they're too confused at the start. So students are going to need to know how to fill one of these out for a successful lab, and a guided practice with you guiding them through one of them or 2 of them is very important. You get to discover sulfur with them and aluminum, and I'm going to go through one of them with you now. So we're going to look at sulfur. Again, this is the cool element that comes right from a volcano. So if you smell it, it smells like a volcano.
Yeah, so this sample is going to be from our Ultra collection. It's just going to be a teacher sample. One of the reasons is because it's kind of stinky. I don't know how to describe this smell, but when you smell it, that is what a volcano smells like. This is the smell of a volcano. These come out of volcanic vents called fumaroles.
Now, we gave sulfur as the teacher guided practice because we don't really want every kid to have sulfur. It's a little bit stinky, but it's an important element because it's not a metal, and so they can see one pure element that is not a metal, but they don't know it's sulfur. It only has the abbreviation, an S. So the abbreviation is important in the science world as we are trying to write chemical formulas. If we don't have abbreviations, our chemical formulas would be so hard to read. So these are standard. Every country uses the same formulas, the same periodic table, and you look through it with them and you say, okay, let's find sulfur, and you'll help them see, okay, oh, there it is, sulfur. So you start there, then you look at the atomic number. These elements all have numbers, and those numbers correspond to how many protons they have in their nucleus, and see, 16. Okay, so we've got 16 protons in the nucleus. We also have 16 electrons. And the group that it's a part of, here you've got non-metals, and that's where your sulfur is. And so each group is labeled here. And so we're going to label our non-metals. Non-metal. And the color, they can get very descriptive with the color. Good scientists have to describe what they see. So I'm going to call this like deep yellow. We're going to say the phase. This confuses them. So it's a good way to help walk them through is that a phase is obviously solid, liquid, or gas. What is the phase of that element at room temperature? So when it's sitting out on your desk, what is it at? Well, obviously this is a solid. Now, for magnetism and conductivity, we've got things here for you. It's fun to have a student come up and do this little test with you. And so you can hold the sample and they can hold the magnet and they can see, oh, it's not magnetic. the next test you'll do is your conductivity test. And this is a very easy thing to do. You've got your Christmas light here and your 2 alligator clips. And all you need to do is clip your battery. So if you put your alligator clip on the little knob of that battery, and if you touch your alligator clip to the battery, you complete the circuit. Now if you put this element in between, it does not complete the circuit, so you know it is not conductive. Take the copper, this is something from their lab, you can see that it is conductive. So if you try and let the kids have this at their desks while they're doing the lab, it's distracting. And so they don't focus on the elements as much. But if they get to go to a station and then do their tests, so you'll have one Sami Sampler at your conductivity station, then they can go through the elements, you know, and test how they're conductive or non-conductive. If you give your kids magnets at their desk, it's going to distract them from the elements. So when you run it that there's a magnet station, then all of a sudden they can bring their element and see if it's magnetic or not and fill out their notes. We recommend that you do 2 teacher practices with them. So as you lead them through this on the first one, they can follow along. But on the second one, you'll find out how much they listened and learned as they try to do it themselves. So everyone in the class gets a piece of aluminum and they all get to take a stab at filling this out by themselves. But you'll get kids that you can tell weren't really connecting with you here because all of a sudden they can't find out what in the world the phase means. And so this is where you really find out, oh, this is where the gaps are. So then you fill in those gaps, and when everybody has completed aluminum by themselves, that's when Sami Sampler gets to come out of the COA and go to all the kids in the class.
Oh, Phil, this one though is really squishy. With these ones?
There are 6 Sami Samplers in your COA, and they have 6 samples each of all the same. So that table groups or groups of 6 students in a line, they can each have their own sample, but then pass it to other students. So the kids can get that experience that feels very scientific with taking it out of their vial and putting it in their hand and looking at it and feeling it. And once they've observed it and put it back in, they can trade it with their neighbor and get a new one until they've worked through all 6 of them. And it might take your class more than 1 hour to do this lab. We suggest that you give it 2 class periods and that you cover 4 elements per class period. It really does take the kids a while to work through this. If you choose, it's kind of like a crowning glory of the lab. In the 2nd or 3rd lab you do this, you can bring out your gallium. This is gallium, and we are including it as an ultra rare teacher sample. Now, gallium is environmentally friendly and non-toxic and used in a lot of applications as a substitute for mercury. And it has a very low melting point, like I said, but as a teacher, for you to be able to show this to your students really makes the periodic table come alive for them. They can see that, oh my gosh, there's a metal that just melted in my teacher's hands. That's amazing. So if you want, as a teacher, you can do this. If you want to just hold the vial for them to see and tell them about it, they can even hold the plastic vial in their hands, and after a while it will get liquid. So as a teacher sample, the gallium is really fun to demonstrate to them, but not recommended for them to hold because it is really messy. If it were to spill, it falls as a liquid metal, but it solidifies in your carpet. So just hold it in your hand if you want to have this rad teacher demo. And then when you want to put it back, you just kind of let it drip back in. And you can see it leaves a little gray residue. So the gray residue is gallium oxide, so it's combined with oxygen in it. It's the equivalent of rust, but for gallium. So allowing your kids the time to cut out their pocket pet cards is really valuable, because throughout the year we do a lot of activities with their pocket pet cards. And as adults, we might not realize how psychologically important this is for a kid, but kids love collecting, and they love collecting what they've learned. And there is informational text here, and there is their own notes and observations. So instead of just having this paper go home and get crumpled up, they can take all their cards and stick them in here, and by the end of the year, you know, they'll have probably 30 plus Pocket Pet cards in their Finder Keeper, and it's like a mini journal of everything that they've learned. And so I'd encourage you to do this with your class. It kind of helps bring together all of the illustrations and their scientific knowledge and their reading and all of their things they've done in this little mini journal.